All right. So my first thing, I'll show 2 slides, and that's it for slides. The rest of the session will be scripted and from SQL Plus to SQL Developer. Myself, as James said, I've been working with Oracle since '97. PL SQL since birth. My dad was a DBA with Oracle since '84. So at the age of, I think, 7 or 8, I did my first PL SQL programming. My 15 minutes of fame in the Oracle world is probably the nose job video. Watch that later on. It's pretty fun. It's a it's an answer to IBM's outsourcing at a customer site. As James said, I work for Miracle. I joined in 2003. I'm employee number 11, and now we're about 300 employees. We're partners with Oracle, Red Hat, Microsoft, and we do everything from hosting to consulting projects. But most importantly, we do beer as well. We have our own brewery. So yeah, that's about it. Let's get started. I'm going to talk about a couple of different packages that you may have heard about. Some of them, but most of them I usually don't see people use. The first one, oh, hang on. I'll start out by creating a demo user. You can get all the scripts later on. I'll create a user called Redgate. I'll give him everything it needs to do this demo, quick and easy. Give him resource in DBA. At some point, I'm using the procedure called show space, which, all credit due, is written by Tom Kite. A really good procedure just to show how much space a segment uses. And I'll create a couple of demo tables. And if I can upload large zip files later on, I'll upload the demo tables as well. They're pretty big. So let me just get started and create the demo user. Oh, hang on. Let me just disconnect. So we should have a demo user called Redgate now. And let me hide this one down here for a while. The first thing I'm going to show is a package called DB version or DBMS version. Now, you can do this, or you can use this package if you create PL SQL that depends on what version the database is. So for instance, I have a small utility called Oracle Stats Compare. And in here, I need to know if I'm running on a version 10 or version 11 of the database. The reason I need to do this is because the script actually runs a function from Util HTTP. So as we all know, from 11 and on, Oracle has created access control lists. So to limit the amount of network access you can do from within the database. So when I install this script, I need to know if I'm version 10 or less. Now, if I'm greater than 10, which means I'm on 11, I need to create a ACL. So you can call this package called DBMS DB version, and it has a function for all the major releases of Oracle. So you can test inside your PL SQL code to make sure that the code that you're running will actually compile against the version it's running on. Let me run this. and we'll install this tool on the Redgate user. Now, we'll use this tool later on so you can see what it is, but this is just a quick demo of DBMS dbVersion. It's really nice to have because generally we write code that needs to run against different versions of Oracle, and now we can have all the code in one package and just have it compile against the version that it needs. The next one is a package called DBMS Alert. Now, probably most PL/SQL developers have at one point in time written a function or procedure to check if either a supplied name is a valid name for a table or a user, or we've written functions to test whether a table exists before we insert into it or before we create it. Now, DBMS Alert actually gives us fully access to the Oracle parser. So we can test if a string is actually a qualified SQL name. Now let me minimize this one here so we can see the code. My first procedure is basically just a test to see if my string is a valid Oracle name or a object name. So my first string we'll test should work out. And then I'll try a string that's invalid. It starts with the %sign. So let's compile the procedure. And it ran okay. And let's test it. Oh, hang on, let me enable DBMS output, sorry. We'll test it again. Now down here we can see we can test even bigger table was a qualified SQL name, and our second name with the %sign in front of it was not a SQL name or a valid SQL name. Now, as I said, probably the best feature from this package is if a user already exists. So it has a function called schema name. So I simply call DBMS Alert schema name and give it this variable, and we can find out whether that schema exists or not. So it compile, and we'll run to test it. And as you can see down here, the user Redgate does exist right now. Another thing it has is the function called SQL object name. So we've all tried to create objects that already exist. Now we can use this package to just check beforehand, so we don't have to run the select count from DBA objects where object name equals and owner equals select that we all usually write. So let's create the procedure. And we'll test for big table, which is the name of a table that already exists underneath the Redgate schema. And we'll test against a table that does not exist. Now, a small hint or a nice thing to know is that these functions do not return true or false. They either return the name that actually exists or is a valid schema name. If it fails, it throws an exception. So you just need to know that. So I think, did we compile it? Yep. And we'll see. So big table does exist, and our second call with the object name shows us that it does not exist. So that's DBMS Alert. One thing that came along in new version was parallel execution. So we've all tried to do either a large update or a big insert or a big delete that we would like to sort of split out into different threads. And we've probably all written our own tools to do it. Oracle supplied in version 11 a package called DBMS_Parallel_Execute. And it basically just helps us split out the work task and spawn a number of jobs that run those individual chunks for us and keeps track of all the chunks. So we can ask and see how many of the chunks are done, how many finished with success, how many finished with error, so we can actually rerun those chunks that finished with an error. I'll start out by just running an update against big table. If we do a select count star from big table, you can see that it's approximately 5.3 million rows. So it's a pretty large table. I'll start out by a call. If you remember my first, where I showed the DB version, I installed a tool called StatCompare. It's basically a webified version of Tom Kite's stats tool. So I'll run the first call to sort of start gathering statistics on our session. And I'll set up the update because it will take a while. And while that one is running, I will show you the code in a different window. So DBMSParallelExecute is kind of like a scheduler job. So you start out by creating a task. So the task is an Oracle name, so it has to be unique. You cannot have a table name that's called task1 symbol, kind of like the new thing in DBMS scheduler. And then we tell the ParallelExecute package how we want to chunk our workload. Now there's a couple of different ways to do this. The first one I'll show is the simplest one, which is by row ID. So we say create chunks by row ID for this task, for this user, for the big table, and we tell it to do chunks of 500 rows at a time. Then we write our statement for the ParallelExecute package. Now it needs to contain this hint. This is the way that ParallelExecute actually recognizes this statement when it's being executed, and this is the way it keeps track of it. So we can update our big table. We can set the column pheromone trend guess. These tables are from a online trading system. We'll do the same update as our first one, which updates the entire table in one statement. And we'll say where row ID between start ID and end ID. And then we tell DBMSParallelExecute to run that task. So we give it the statement, tell it what kind of SQL it is. And the important thing here is the parallel level parameter. By default, this value is 1. So if we would run it with the default value, it would run just like the normal update one. So it doesn't run very parallel with default values. Now, I also keep track of the status of each task in here. So I'll get the status from the execute task, and while my retry number is less than 2 and the status is not finished, I'll retry that task if it fails. And when I'm done, I'll drop the task. Let's just check to see if our update is done. That one is done. So we'll run the middle compare here. And now let's run the the block where we update by row ID. And while we do that, I can show you a different way of using it. Now, another way to chunk up the parallel tasks is to do it by a number column. So instead of row ID, we can choose to create chunks by number column. So we tell it which task it is, still give it a user, a table, and then we say use this column and the values within that column to create chunks, and create chunks of 10,000. And then the rest of the code is basically the same, except our update statement now says where our chunk column is between start ID and end ID. And we just run it like we did with the other one. This one finished in 35 seconds. The other one ran in about 2 minutes. Let's check if my tool worked. Should be this one. No, that's an older one. Okay. Well, basically, this tool just shows the difference between two runs. We'll get back to that tool later. An even different way to create chunks or to run chunks is to run the chunks manually. So by this, we still create a task. We create chunks by row ID, give it the name of the task, user, table, chunk sizes. We still define our SQL statement. But instead of just running the task and letting Oracle split it out, we can loop through all the tasks and run it ourselves manually. Now, it could be that we wanted to run some different code after each chunk has run. So we can get a row ID chunk, and we simply put in the task name, and we get a chunk ID, start row ID, end row ID, and we get a notice if there's any rows in there at all. And if we have rows, we can execute that statement with execute immediate, and then set the chunk status using a manual call. So that way we can control the entire loop through the different chunks ourselves. So that's parallel execute. The next one, let's close this one, and this one, and this one, is Util match. So I don't know how many of you have written search engines for internal systems or for customers where you have to search maybe in a phone book. So people type in a name and you have to return the number of matches. In the old days in Oracle, you had two choices. One was to use SoundX, which, to put it mildly, is not a very good way of finding out if what you've typed is close to what you actually want. So if we look at the SoundX function, we can see that I have a couple of Danish stock names in here, and if we imagine that I typed in this in the search box, this is the result of the SoundX function. So this stock name is N125 in SoundX, and it doesn't even come close to what we searched to, so that would be a negative in our world. But we also have several matches directly, which is not at all like what we've typed in. So SoundX is not really that good to check if we have a match for a name or for a company name, telephone, whatever. So in Oracle version 11, they created a package called UTL match. Now UTL match basically implements two different ways of searching. They implement what they call the edit distance, which is how many times do I have to edit what we've typed to come to the result that we found. And they've implemented a algorithm called OWAUtil. I have the link for it at the top of the file. So if we take a look at what we can do with this, hang on, let me just show the select as well. So now it shows us that we typed in Nordcom, and the closest match is Nordicom. It has an edit distance of 1, which means we only have to add, change, or subtract 1 character from what we've typed to get to this. The edit distance similarity is simply a percentage instead of a value. And we have a OWAUtil similarity of 97%. So UTL match is 97% sure that we actually meant Nordicom. So it's a really, really good package to do phone book searches, book title searches, anything where you just have to guess what people mean. So that's UTL match. Now, we all know that, oh, no, sorry, we all might not know, but in old days, if you had to communicate between two sessions in Oracle, you would have to create what's called a pipe. So you would create a pipe using the package called DBMS_pipe. And people use this to either create intercommunication between sessions or to send messages from one program to another inside of Oracle. We could, of course, use advanced queuing, but that's kind of cumbersome and needs a lot of code. Now, Oracle has created a package called DBMS Alert. So I'll create a table called raise signal. Basically just a table that we will be inserting some tables into. I will then create a trigger called send signal. So after each insert for every row, I'll send a signal to a let's call it a signal name. So the name of the signal will be signal name, and I'll send the message someone inserted a row with the value of, and then what they inserted into the rnum column. So let's create the trigger. Oh, sorry, let's create this in SQL Plus because of the colon down here. We'll create the trigger send signal, and then we'll create the program that will actually listen for this signal. So in another session somewhere, we'll have a program that goes through some code, and then to finish, it needs to receive the signal. So we start out by saying register, and then we tell it which signal we want to wait for. Now this is session-based, so only this session will have the handle for the signal. And as soon as we exit the session, the listen or the listener for the signal will disappear. Now we will wait for one signal. We can wait for many or wait for any if we want to. And then we'll basically display the signal message that we got. So let's create the procedure. and we'll call it from our DOS prompt over here. Hang on. So now you can see this session is basically hanging, waiting for someone to send us a signal saying, we inserted a message or inserted a row. So let's take and let's do an insert. We'll have to do it in another session. And we'll do the insert. And let's see if we can get both DOS prompts up here. So as soon as I commit, my trigger will commit and it will send the signal. And there we go. So in another session, we actually got the message that someone inserted a row with the rnum value of 42. So DBMS Alert is a quick way of communicating short messages between sessions. This is not to be confused with advanced queuing, where you can basically communicate with complex data types, lots of data. This is based on a varchar 2 message, and so it's limited to 32,000 characters. But it's a quick way of sending a short signal to another session. Now the next one I personally really like, which is the package called Util_compress. So Oracle got compression in, can't remember if it's 10 or 11, but most of the really good compression features are, I think they're a price option or an enterprise option. But Util compress is a standard package. So I thought you should be able to actually create the same functionality with Util compress as the compression feature does. So I'll start out with to create a function that compresses content. So it takes in a varchar 2 parameter, and it basically just casts that text to raw and then compresses that raw data and returns the compressed data to us. So we need this when we I'll try and see if my tool will work. So at first we'll just create a table called noCompress, where we'll have the content as it is, as the text that it comes from. I have a table called News Store. Basically, it's just about 28,000 different news articles from the last year, and I'll put in that into the table. And I'll try and keep timing on how long it takes. So we'll create this table. It will have about 26,000 rows. Then I'll create a table called doCompress, where we will put in our compressed content and try and see the difference between a normal table and a table with compressed content. So we'll create the table, and then we'll run the insert, where we will insert the same data, except we will compress the actual news content or the actual article text. We'll do a commit. Let's see if my tool works. Here we go. Now it worked. So I've created a measurement between red gate compression insert. So insert without compression, of course, will run faster. So it ran in about 20% better than with compression, but it's not that great a loss, because if we look at how the actual data usage is, we'll close this one and open DBMS output. So at first, let's take a look at how much the no compression table takes up. So as we can see in here, it takes up a total of 17,500 blocks, and it's just about 140 megabytes of storage usage in Oracle. And if we take a look at the table where we put in the compressed data, we can see that it uses less than 50% of the blocks, and it only uses about 52 megabytes of data storage. Now, if you want to select the data, we would fail if we just select star from that table, from do compress, because we wouldn't have any content over here. SQL Developer can show the blob column, but it doesn't know what it is. If we would do this in SQL+, we would fail. Oh, no, it shows the blob, sorry. But still, it shows us the compressed content. Now, instead of showing us the compressed content, I will create a pipeline function which will basically do the uncompress while we do the select. So I have to create a type that matches the original table. And I'll create a table of that type. And I'll then create a pipeline function. Now, for those who don't know, a pipeline function is a function that can return rows as if it was a table. So instead of just returning one value, we can return rows as they are created. So you can select from a pipeline function and get the output as a table. So inside my pipeline function, I have a cursor that selects the data from our compressed table. And while we loop through every row, we will uncompress it and pipe that row back to the prompt. So let's create that pipeline function. And we'll see what the difference is between selecting from a normal table and from a pipeline function that uncompresses our data. So we'll start a new compare. And let's select the actual data as well. And as you see, it ran in 0.044 seconds to get 50 rows. And now instead of the compressed data, we can actually see that it's a HTML article from the web. So we'll run a compare in the middle to make sure that we have data to see the difference between this. And we'll select now from our pipeline function. So the keyword here is from table, and within those parentheses, you give the name of the pipeline function. So that will dynamically fetch every row from our compressed table, uncompress it, and show us the content. And as you can see, the time difference, not that big, but we save almost 60 to 70% of space within the database. Now granted, I made it easy. I created my tables with a varchar instead of maybe a club or a bigger data type. But it should be pretty easy to rewrite the function to just return a compressed club instead of a compressed varchar. If we go and take a look in here, we have a compression select. And we can see basically the uncompressed runs in about 5% better timing. But the important thing to notice here is that we use the same resources on inside Oracle. Of course, we use more CPU in the second run. That's the red line here. The first one is the first run. We use more CPU because we have to uncompress it, but the amount of time we spent within the database to get the result out was the same. Also, if we look at the time model, we can see that DB CPU is almost double, but DB time is basically the same. And we spent the same amount of time doing all the other stuff inside of Oracle. So SQL elapsed time is, as you can see, almost the same as well. So UTL compress, really, really good package. A package called UTL_InAddress or internet address basically just gives us the functionality to look up IP addresses or host name and see what they matches. So we'll run this as sys. I'll create a ACL. This is not part of the demo, but basically that's just give us the allows us to actually. Oh, hang on. I think it's already in there. I forgot to drop the ACL before the demo. So the ACL, the access control list, is inside the database already. But basically what it does is it tells us that we can resolve any host, and we can do it, connect to any host between the ports 1 and 32,000. So if we take a look at the procedure, what we'll do is we'll look up the host name of my computer. So we'll take my localhost IP address and see what it resolved to as a host name. But we'll also take my host name and see what IP address that resolves to. And then what we'll do is we'll look up an IP address on the internet and see what host name it resolves to. I can tell you that it's the IP address of this website. And we'll also look up the IP address if we have the domain name. So we'll take this procedure and compile it as this. And we'll run it. So we can see that my 127.0.0.1 IP address resolves to Mac PC, but my Mac PC resolves to my IPv6 address instead of my IPv4 address. The IP address of my external website resolves to a machine at my internet provider, and the host name resolves to the IP address locally. So the UTLInAddress is a quick way just to look up IP addresses, look up host names. Mostly I use it for the local stuff. So I sometimes have PL/SQL programs that needs to get the host name of the machine they're running on. Then this one is very handy. Or if we need the IP address to do FTP or whatever, we can go by the host name. So a quick way to just get network information. A package that comes with OWAUtil. It's a packet that gets compiled in the database if you install mod PL/SQL. It's freely installable. One nice thing it has is it has a function called Who Called Me. So we can get a call stack from our PL/SQL. So we can basically see, we'll create a procedure called test OVA that calls this function. There we go. and we'll create a procedure that basically just asks whoever called me. So we have TTOP, and if we execute that, we can see down here that the user Redgate with the name TTOP, we got called from line 4, and it was a procedure. So it's a really, really quick way to just get information about where we are in a SQL program or a PL SQL program. I use it a lot for debugging. Now the last thing I'll show you is the Apex Util package. Now I'll just show a couple of quick things, but it has a ton of nice conversion functions or procedures to do stuff that you basically don't need to write yourself. So for instance, it has a function called getSins, which basically just gives us a string that says, oh, sysdate minus 0.45 is 11 hours ago. Sysdate minus 2 is 48 hours ago. If we get more than 2, it tells us 2 days ago, and it doesn't round up, so we need to change this to 3 if we need 3 days ago. Oh, hang on. There we go. Another package or a procedure that comes with the Apex Util that's good to know if you create password procedures is that Apex has a pretty good validator if a password is strong or not. So we can actually just reuse that function or procedure. It's called Apex Util strong password check. So you type in a username, password, the old password. We'll just type in a blank workspace. This is only if you use Apex. And we tell it to use the strong rules. So we'll have a minimum length. It has to differ from the old one. It has to have at least one alphanumeric character, one numeric character, one special character. And we'll create a procedure called pcheck that can check a password. Let's clear this. And we'll call it with the username manager and manager. So our old password was manager and our new password is manager. And I checked only 3 different things. If it differed from the old one, if it contains a numeric character, or if it or if it has a special character in there. And as you can see, they look the same. There's no number in there, and there's no special character in there. So that is my presentation of undiscovered country, unused packages within Oracle. I hope you could use it. If you have any questions, please ask away.
Hi, Morten. Well, thank you so much for going through that. It was extremely interesting, and I hope everybody shares this with me. A lot of questions have already come in, so I'm going to get started with those. Please bear with us. We might need to organise them a little bit. There are obviously some topics that have been repeated. As Morten said, though, but if you do have more questions, please type them into the question panel now. A couple of quite common questions that have come up are regarding the recording of this and also the scripts that Morten's been using. As I mentioned at the beginning, the recording will be available on the Redgate website. The recording and the scripts will be available on allthingsoracle.com. And one of the things I also mentioned was the great thing about accessing this on All Things Oracle is that you can ask other questions and you can comment using the comment section on the website about this webinar, put questions in there. Maybe you have some packages yourself that Morten hasn't shared that you know would also be useful, some things that aren't commonly used by other people, to be a great place to share this information with the community. Okay, so let's go to the questions then.
Should I start from the top or?
So I'll go down this list, Morten, and I'll put the questions to you. Okay, so for a question here from Syed Lakewet. Thank you, Syed. He's asking, it seems like SQL_object_name and qualified _SQL_name are both the same. So this is in reference to the beginning of the presentation.
Yeah, hang on. Let me get, that was the DBMS Alert. So he's saying basically qualified is the name, and which one? Can you repeat the question?
So it seems that SQL_object_name and qualified _SQL_name are both the same. Is this, should this be like this?
No, that the qualified _SQL_name basically just tells you if the string you supplied is a valid SQL name. So it doesn't check if it exists or not, it just tells you the string supplied would be a valid schema name or table name or object name within Oracle, whereas the SQL object name tells you this actually exists inside the database.
Great. Thank you, Morten. So a question here from Paul Scott. Thank you, Paul. Are any of these packages dependent upon Oracle licensing options? The example that Paul's given is DBMS_parallel_execute.
Whoa, I honestly don't know. I will have to check. As far as I know, most or all of the packages are standard packages, which should be available in both Standard Edition and Enterprise Edition. But I can verify that and put that on the All Things Oracle website afterwards.
Great. Thank you, Morten. The next question from Pavan Kumar. Thank you, Pavan. And he's asking, is it possible to display the output of an anonymous PL/SQL program while it is executing, similar to a pipeline function which return it in parallel using DBMS_output?
No. So DBMS output is a block program. So basically, it only shows once the PL/SQL block is finished. So even though you could, if you created a program like this, declare cursor get all data is select star from big table again for X and get all data loop DBMS output dot put line X dot sum column and loop. So if you write an anonymous PL/SQL program like this, if you don't know DBMS output, you might expect that the SQL Plus will pull out rows as it goes through the data. But basically, what Oracle or SQL Plus will do is it will finish the entire loop and then show you the data. So once you see any output from DBMS output, you know that whatever you executed is done.
Great, thank you. The next question from Jürgen Schauser. Thank you, Jürgen. He's asking, why do we need the DBMS_parallel_execute package? Does the database not do it by itself if the parameter is set?
True. It can do it by itself, but I showed the simple ones, which is like chunk by row ID or chunk by something simple. But you can write much more complicated chunks where you basically chunk it out by a combination of columns. So you could write more complex parallelization of your SQL query, and you can get complete control of it. If you let Oracle do the parallel execute, it will basically executed as soon as you submit your query. With with DBMSParallelExecute, you can control the execution. So if you remember, I'll just show it just a second. My third demo here. This is where I manually go through all the steps. Now in my demo, granted, I don't do anything extra, but it could be that we wanted to parallelize a operation, but we had more code that needs to run before we basically process each chunk. So parallel execute is, you can do more complex parallelization than Oracle can do. Yeah.
Thanks, Morten. A follow-on question here, actually, from Florian Altin. I hope I've pronounced that correctly. Thank you. It's to do with DBMS_parallel_execution. In one of the scripts, you used the chunk by number column and still added the row ID. Hint. Is the hint necessary every time we use this package?
Yes, it is. It was in the first release of 11. I haven't checked in 11.2, but in the first release of 11, you needed that hint for all the internals of parallel execute to work.
Thanks, Morten. And Kate Johnson also asks, how is the start-end row ID supplied?
How is the what? Sorry?
The start-end row ID supplied.
So if I let Oracle do everything, we can take the row ID one up here. So I create chunks by row ID. I tell it the user, I tell it the table, and I tell it to do it in chunks of 500. I give parallel execute my statement that it needs to run in every chunk. This statement is basically passed on as a variable to a scheduler job. So the scheduler basically just gets an input of where it is. And the DBMS parallel execute maintains a cursor where it selects the row IDs. So if you look at my where I basically do it manually, this is what happens underneath parallel execute run. It basically just splits out a number of scheduler jobs in chunks of whatever limit I set, and within that scheduler job it has an anonymous PL/SQL block that does execute immediate and takes the statement that I inputted and binds those variables, and all of them are basically just input arguments to a DBMS scheduler job. So you can say that DBMS parallel execute is just Oracle's way of writing something that we could all write with DBMS scheduler.
Great, thank you. Thank you, Kate, for your question. Kate is also asking about can multiple listeners, sessions, listen for the same signal?
Yes.
Fantastic. And Eric Fall follows on by, what is the wait event when a session is trying to wait for the signal?
Don't know. Let's try and see. I haven't actually looked at that. So DBMS Alert. Let's get this. Pipe get. So it looks like they're using DBMS pipes in the background.
Thank you. Jimmy Brock has asked, thank you, Jimmy, could you explain the differences between DBMS_alert and DBMS_pipe?
I think I just explained it. They look like they're the same, but well, you can say that the DBMS Alert basically simplifies the amount of code we need to do. As I remember, it's been a while since I've done DBMSPipe, but I think I would need a couple more lines of code to make this work with DBMSPipe. So it like the DBMSParallelExecute, it looks like Oracle just basically created a package that's more usable for users.
Okay. Thanks, Morten. So the next question from Jason Bukasa, I hope I've pronounced that correctly. Jason's asking, in reference to the compression demo,
yeah,
would a view with a function in the select list also work?
Yes, it would. So you could have a normal view with normal columns where you didn't have to write from with the table clause. I'm guessing he wants to get rid of this stuff here. So normal users would just see a view. Yeah, you could put that in a view. No problem.
Fantastic. Thank you. Next question from Jacob Anderson. Thank you, Jacob. In what cases would it be an advantage to do the compression yourself using UTL compress compared to using compression on table space level? And did you do any testing regarding the speed of compression yourself versus table space compression?
I haven't tested the speed difference. What I thought, and I might be wrong, but I think compression on either table space level or advanced compression is a enterprise edition feature, and that UTL compress is a standard edition feature. So I made this demo because I wanted to show that you could get almost the same functionality from standard edition.
Good. Thanks. Eric Olson is asking, thank you, Eric, could you put a virtual column on your compressed table that did the decompression without having to create the pipeline function?
My initial guess would be no, but I am willing to create a test tonight and put it on the All Things Oracle site for you tomorrow.
Fantastic, thank you. We've got a few questions in about the web-based tool you're using. Could you tell us a little bit more about it, please?
I could. Basically, I used to use Tom Kite's runstats a lot, and I had a lot of customers that didn't like the output. So bosses tend to need graphs and pie charts and stuff like that. So whenever I was at a customer site, they tended not to look at my report if it included run stats from Tom Kite. So I generously took/stole his code and rewrote some of it, and I created a web-based version of it. So you call it the same way that you would or Tom Kite's run stats. You have a start compare, and then you run your first part of your test. You have a middle compare, you run your second part of your test, and you run an end compare. And what this does, it basically, instead of collecting the data inside your database, which Tom Kite's runstats does, so it runs locally, this tool uses a package called Util HTTP to upload the data to a website. So if we take a look at the actual function, go through past the install part, this is my UTL run compare package, and it basically uploads the data to the site instead of storing it locally in your database where you're running the test. So you will need to have a access to the internet from the database server. But as you saw when I installed it, I can run the install again. Hang on. Let me get the other one. if you're inside a company firewall, you usually have a proxy server that you can use. So you can type in the proxy server and port, and when you install it, and your database server will be able to use that proxy to send the data. I don't collect anything that that tells me anything about your database. I only collect the stats from the different stats table, basically the same code as run stats. And instead of storing it locally, I just upload it to my website. And as soon as you run the end compare, you can access the report from the website. You can use it anonymously instead of creating an account. So if we exit here, I have a test. Hang on. You can simply run start compare without any parameters, without any key to the user account. Run whatever test. Oh, hang on. Run the middle compare. Run whatever second part of your test that you want to see. Run the end compare like this. And then when it's done, you can run, hang on, this select, oh, hang on, and basically see an anonymous version of the report that you just ran. And basically now you have a free code that you can use for, I think it's valid for about 4 hours, then I delete it, and after 12 hours I delete all the data that's in there. And on the website you can download the code, you can see examples how you do it, if you have a key or if you don't have a key. There's all types of options you can give to it. Yep.
Great, thank you. There's a question in from Ivan Nosenko. Ivan, it's split up between some other comments. If you could just jot your question down to make it a little bit easier for myself to read it out and for Morten to answer it, that would be great. So we're going to move on to the next question whilst I let Ivan do that. Also, Ivan, maybe Morten has answered some of this already, but do please let us know. So, Alexander Tokevra, thank you, Alexander. Again, I hope I've pronounced your name correctly. He's asking, if we set the level of parallelism to 4, does it mean we have to run 4 jobs simultaneously? Or do we have 4 jobs simultaneously run?
Hang on, let me go back. So he's thinking about the parallel level of parallel execute. So basically this means that parallel execute package will make sure that at any given time it will run 4 active chunks. And whenever one chunk finishes, it will start the new one. So it will try and run 4 active chunks at a time. I don't know if it answers the questions or not.
Thank you. Next question from Bojin. Thank you, Bo. For DBMS_parallel_execute, does the whole job have one starting scan for read consistency, or each chunk has its own starting scan?
Each chunk will have its starting scan.
Fantastic. Okay, so hopefully, there are, I think a lot of the questions that maybe we haven't come to seem to have been answered. If you do have any further questions, now's the time to put these into the questions panel. As I say, I do hope that the questions that have already been asked have been answered. Reginald Bailey, thank you, Reginald. He would just like you to show the DB piping website URL again.
Yep. Hang on.
As Morten said, we're going to put some information about this on All Things Oracle, so you will get access, or you'll be able to get easy access to this website. We can put a link up there.
So that's the URL. I'll put it in all the stuff that I put up.
Thank you. And Kate Johnson's question about allthingsoracle.com. All of the content is freely accessible on All Things Oracle, so you won't need a password to get access to the recording or to any of these scripts. Okay, so thank you again for joining us for today's webinar. I've just put some contact details up on the screen. Please contact Morten Egan via LinkedIn. I've got some contact details for myself there. Please feel free to contact me through Twitter or my direct email. So I'd just like to finish off by saying thank you to Morten for presenting today's session. I hope you've enjoyed it as much as I have, and I hope you've learned as much as I have. Thank you also to everybody that has joined us live for the session. Again, I hope this is something that has been useful for you. So I'd just like to say goodbye to Morten.
Goodbye.
And goodbye to everybody that's joined us, and I look forward to talking to you again on the next webinar. Thank you, and I hope you all have a nice day.